All right. Hello and welcome to our vast customer training webinar. We have a very exciting webinar for you today. This is going to be one that even our internal teams have talked about being very excited to get to see in action and have you see. So if you are newer to the VAST management system as an admin, we do have some great additional training resources for you. I will put those in the chat. But today we are going to be talking specifically about automating fast storage systems. So with that, I'm not going to give much more of an intro than that. We have lab links that I'll put in, and this is really a chance for you to hear about something new and how to use it. We've got our special guest, Jonas Roslin, our Director of Community at Vast Data. So I'm going to invite him onto the stage. I'm Kristen, the Director of Customer Education. And Jonas, I'm just going to pass it to you to get to share with these folks this really great information.
Fantastic. Thank you, Kristen. And thank you, everyone, for joining today. This is going to be a very interactive session. So if you have questions, please put them in the Q&A. We're going to answer questions throughout the presentation and also at the end. So please make sure that you utilize the Q&A function there so we can capture your questions as they come in. This session, we're going to be talking about automating your VAST management system or programming towards it, rather. We're going to be using two specific Python libraries for this. We're going to be using vastpy and vastdb SDK. So with those, we can automate a bunch of administrative functions and also get some really cool workflows going. And this will help us when we move towards implementing pipelines within our systems later on, and also just to elevate your own management of all these systems. So this session is mostly tailored towards administrators or infrastructure operators who are used to the VMS, to the VAST management system, and also to any folks that would relate to DevOps when it comes to automating and scripting your infrastructure and utilizing infrastructure as code. So with that focus, we're going to be talking about vastpy and vastdb SDK. So let me share my screen, and I'm going to be showcasing a bunch of things. All right. So as you can see here, I have some code bases here to the right, and I'll show you what these are in a bit. But as you can see here, we have our GitHub. If you haven't seen Vast Data's GitHub page yet, I highly recommend you go there. And in there, you can see all of the open source projects that we manage, or some of them we are contributing to as well. And as you can see, two of the more popular ones are vastdb SDK and then vastpy. We also got VUA, which is Vast's unidentified attention that we announced earlier this spring. We have Vast CSI for our Kubernetes environments. We have a Vast exporter for Vast to export things over to Prometheus. And we also have a fantastic VLM by Matt Rogers, which is a multimodal LLM for video, which is really cool. So I highly recommend you check that out as well. So the tools that we're going to be talking about today, again, vastpy and vastdb SDK. So what are they? Well, vastpy is an SDK for interacting with the VMS REST API. So this gives us a really easy and easy to use interface to manage our storage system through Python code. And this is really, really cool because it means that you can, instead of clicking through the UI, you would set all your parameters in code and then execute it, similar to what you would do with configuration management tools such as Puppet or Chef or Terraform, for instance. So with this, you can then add views, you can add quotas, you can manage users, you can create a basic chargeback report that I'm going to be showing as well, because that was a request that I got from last week. And it's just a really, really good way of managing your system in the same way consistently every time. Because once you write this code and you implement it and you start using it, all of these operations are going to be done in the same way every single time. So if you have 5 administrators for the VAST management system, you would probably have 5 different ways of doing things, or different ways of getting to where you should be when you're managing the VMS. So with this, you can then, instead of having all those 5 different ways of doing the thing, we have one singular way that's always the one that we're going to be using. Give me 1 second. I'm going to be moving this over here. There we go. vastpy is very simple to get started with. Within the repository here, we have a few quick start examples. It is available on pip for those who are used to importing modules for Python applications. This is super simple, and same thing for vastdb SDK. That is also a pip installation. To authenticate here, of course, you can use your user or your username or password. With 5.3 and later, so if you're on 5.3 or later, 5.4 coming out soon, you can also use an API token and a tenant name. But if you're not on 5.3 yet, you can still use your username and password to authenticate to the system, so you can verify that you can actually log in and you have the right permissions to do things. We also have an example here of obtaining an API token. But as you can see here, there are some examples of view management, snapshot management. These are very basic and easy to understand examples. And I'm going to be diving into how these could be used at a fictional company as well. We also have some monitoring. And of course, we also have a command line interface. If you're more inclined to use a command line interface, you can do that instead of creating your own applications or scripts like the ones I'm going to be showcasing today. So the vastpy CLI, here you can see that we can do certain things as well. So we can list our snapshots, and they will be listed in a JSON format. We can create a new view here, where we use a post command. And we create a new view here, the path. We're going to create this directory, and we're going to be using the policy ID number 1. We can also create a new snapshot here of a specific path and name that snapshot. You can also have complex operations here where you use a JSON file as input if you want. All of the API documentation is available on your own VMS. So if you head over to your VMS/docs, you will find all the API documentation there. It is also available on our support portal, so you can find it there if you want. Then if we head over and look at vastdb SDK, this is another SDK for interacting with the VAST database and the VAST catalog. If you're not aware of the difference between the two, the VAST database is essentially a replacement for a lot of databases out there, while the VAST catalog is more for metadata around what's being stored on the system. So with the VAST database, you can input whatever schema you want, essentially, and also fill it with important, crucial information, while the VAST catalog will give you utilization and information about the metadata around specific objects, specific files in your VAST data platform. So with that, we're going to be focusing on the VAST database for the demos that I'm showing today. Same thing here. You do a pip install vastdb, and then we have some quick starts here. One of the caveats that I noticed is that you need to have a specific Python version. When I first started using this, I was using a Python version of 3.13, and that doesn't really work with PyArrow and other things. So make sure that you have versions here 3.9 to 3.12, and you're going to be just fine. Here's a quick start on how to use this as well. And one thing that you might see here is that we're using access keys, which is a little interesting if you're not aware of how the VAST database works. The VAST database is essentially controlled or has an ACL similar to a bucket. So we're using S3 policies with tabular permissions, and that way we get access to the database. So if you see bucket, as you can see here, using buckets as the database. And yeah, you can see a bunch of more information here. Highly recommend you check this out. It's a great project. And while you're in there, if you're logged into GitHub, make sure you give us a little star on both the vastpy and vastdb SDK if you like what we can do there. So on to the demos that I'll be showing today. Let me see, do we have any questions before I go forward?
Hey, Jonas, just a quick note. I know you've got limited control on your side, but we're having some feedback on the fonts being a little small. If there's a
Oh,
way you
yeah,
can zoom in just a little.
absolutely.
Thank you
Absolutely.
very much.
I hope that's better. Thank you. So the labs, again, or the demos that I'll be showing here are actually public already. So if you would like to test these out in your own environment, you can head over to our Cosmos labs over on our Vast Data GitHub org as well. Within these labs, right now we have 2 advanced labs, and I'm going to walk you through those. And I got 6 different examples, as you can see here to my right as well. The examples are basic examples of what you could do with vastpy, and it's a great introduction on how you can utilize vastpy and then also format the output in a really nice way. So it's easy to use and easy to understand. So thanks to Python, we have a bunch of tools at our disposal, which is really, really nice. And yeah, these are, as I said, these you can run right now if you want. The one small little disclaimer, though, of course, this repository is only for education. This is only educational code and examples, not for production. So make sure that you review and test any code before using it in your environment. But if you have a test environment that you would like to try this out with, absolutely go for it. And this will also be live in the Cosmos Labs within the next week, I hope. We're setting up some hosts where you can actually run this code live on our Cosmos Lab. So if you don't want to mess with your own environment, you're free to use the Cosmos Lab, but you're going to be a little more limited there because we can't have everyone have admin access to that lab, of course. But let's take a look at what these labs entail. So within these labs, we have created a fictional company called Orbital Dynamics. Orbital Dynamics is a mid-sized space technology company that processes astronomical data and manages satellite constellation networks for research institutions. This is just an example company similar to what we see at our customers as well. So I wanted to kind of build out a nice little storyline of why you would use certain things. So within the labs, you will see some interactions between Dr. Alex Sterling, who's the CTO, Maya Chen, who's the lead sysadmin, Jordan Blake, who's the senior developer, Sam Rodriguez, DevOps engineer, and lastly, Mac Thompson, who's a junior admin. Within each lab, you will see a challenge. The first challenge here is monitoring existing storage infrastructure and automatically expand quotas when needed. This is just to show you how we can look at views and quotas at the same time and alert and also predictably scale systems as needed if you want to scale up your quotas. Lab 2 is around building up a metadata database for data discovery and management. So we have a real live data set from NASA called the SWIFT dataset for gamma ray bursts. And with this data set, we can show how we can extract information from the actual files, not just if it's a file and what date it was made, but actually pulling out information from the files and then putting that in the database so we can search for each file for various different metadata. Upcoming labs that we have that we're still creating right now, and I would love for you, if you have any examples of other labs that you would like to see, please create an issue over here. Just create a new issue and explain what the lab would entail and how you would see this fit into how we're trying to program towards our VMS. But we have some upcoming labs, a data pipeline lab, a snapshot lab, and also a more real-time alert system, and then a bit more pipeline integration when it comes to 5.4 later on. Some prereqs for this, of course, make sure that you have Python installed, you have access to a VMS, and the tools here that we need. All of these tools, all of the Python modules that are required are listed in the requirements here. So it's easy to get started there. And for each lab, as you can see here, you also have a little story. Let me see. Yes. So here with the lab, we have an overview. Sorry, not a story. We have an overview, and then exactly how you would run this. So it's very easy to follow along and run this, so you can see what happens on your own environment. But enough talking. Let's get to actually running some of these Python scripts. So the first one that I want to show you is just a very simple one that will verify that we have a connection to the VMS. This is needed to make sure that we have everything configured correctly. Within the root directory, you will see a config YAML.example file. Make sure that you copy this to a proper config file. And you also have a secrets.yaml.example. Make sure you copy that to secrets.yaml and input your own secrets. I'm not going to be sharing the login here, but with this, you can just run these scripts. So let's check out the connection to VAST and see if we can log in or not. And we can. So this is example one, connecting to VAST management system. We're connecting to one of our systems here. You can see my user. Here's me testing the connection, and the connection is successful, the cluster ID, and the cluster name here. And then total capacity, I flubbed this, but I'll be showing that later on. So how does this work? Well, within this script, you can see here, we import from vastpy, we import a VAST client. And using this client, we create a user based on the user and password that we have set in our config and secret files, and also the address for the VMS. And then we're trying to check out, or rather get all the clusters that we can see here through that client. And if we get a cluster, then the connection is successful. If we don't get any information about the cluster, it means that we either put in the wrong username, the wrong password, or the wrong address to the VMS. So this is a very simple script to verify that we have a connection. You can, of course, make this even simpler, but I wanted this to be pretty descriptive to make sure that everyone understands how it works. For the next example here, I'm going to be showcasing how we can list storage views and their status. So let me run this so you can see what it looks like. You can see here, we got tons of different data stores here. As you can see, many of them are not utilized at all, but they are just created for as examples. Let me do this. So you can see more here, and you can see the ones that I'm using here, the Cosmos Lab ones. Some of these are definitely utilized a bit more, so I think I need to verify how the script views those sizes there. But this is a way for you to list out all the views for your environment. And it seems I made a miscalculation there, but otherwise you would see utilization there. If it's over 90, then we're going to be having a red status emoji instead of a green one. If it's over 70, we'll have a yellow emoji, and otherwise it's fine, it's green. The third example here is about quotas. And with this, you can check quotas, and I'm showcasing 4 different quotas that we have set up here. And you can see that we got one quota here for one view. This is the Cosmos Lab processed view. Current usage is 0 bytes. I'm not using this at all yet. Soft limit is set to 100 gig, which is then rounded down, and then a hard limit to 5 terabyte, which is also rounded down there. So you can see utilization is 0. But here we got a warning. We can see that this quota, currently using a whopping 347 megabytes, and the hard limit is just above that. So you can see that we have a utilization of 90%. This is a great way to showcase, just to pull out a list of all the quotas and see which ones that we might need to take action on. Again, this is super simple. Everyone would go through the same method of listing out these quotas instead of going to the UI and looking at the quotas. So this is a very simple script for everyone just to get a very quick view of what the quotas are like right now. The next script is around monitoring health. So this is just pulling some of the cluster health, as you can see here. So we can see the nodes, you can see the node status here. You can see that all nodes are healthy. You can see the cluster that we're connected to. We get proper API response, and our API response is less than 1 second, which is obviously good. We want that. So overall, our system status is great. Here we can also pull out active alerts, as you can see, so we can really dig into this. And if there are errors, we can immediately get that as well. So this is an easy way to build out a monitoring dashboard, so to speak. So very simple. And yeah, the entire file is here. Same thing, we create the configuration from the config in the secrets file. We create a new client, a Vast client. We do this in every script. We point the, we do an API call to get the clusters. We look at the cluster health, the cluster ID, and the cluster name, and then we look at the nodes. We look at if they are okay, if they're not ready, or if they're just installed. And then some basic performance metrics as well, if we have it. the next one, I got two more here. So this one is around snapshots. So for this, because we have tons of snapshots in this environment, because it's a lab environment, it's a test environment, so we have a bunch. So what I did was, within these snapshots, I just want to see the latest snapshot, the oldest snapshot, and the largest snapshot. You can absolutely go and see this in the UI, but you would have three different views for each, or three different views to capture the latest, the oldest, and the largest. With this, we can just do it in one shot. So you can see here, we have 73 snapshots. Let me zoom in a bit. This is the oldest snapshot. You can see the name. It was created at this point. It is this big, and it's for this view and has an ID of 114275. The latest snapshot was this one, taken today, very recently. And you can see here, this is for a replication test. It's also 0 bytes of size and an ID of 251132. The largest snapshot that we have was created on the 21st of August, and it's for this view, and you can see it has a size of 190.3 megabytes. So this is where we can kind of look into utilizing vastpy as more than just a get information tool. It can also be used to collect information from various different sources. And this is really powerful because pretty much everything from the VMS we can pull out from the API. And if we can collect more information into one format or one output here, it helps a lot when it comes to managing and maintaining a system. So this is a really good example of how we can do this. The last example here before I dive into the labs is a chargeback report. This is something that was asked for by one of our SEs here at Vast, where they said, hey, can you give us an example of a quota or a chargeback report? And this is a very simple chargeback report. I put a default rate of $42 per terabyte per month, and I'm only showing the storage cost for root for the views with enabled quotas. This is not the root, but rather root something like root James, root truest prod, and I don't care about replication test, for instance. I just care about James in this instance. So if you want to see what that looks like, this is a chargeback report where we connect to the VAST management system, fetching the storage views, fetching the quota information, we're calculating the cost at $42 per terabyte per month. And then we list the top 5 most expensive root views with quotas enabled. So we can see here, we got 2 that are actually using quotas and actually have data on them. So you can see here, CSG in total, that view in total with everything underneath it, is using 118 gigabytes. So a monthly cost for that would be $4.84. And me, Jonas here, I got one view as well. My total storage is 347 megabytes, so my monthly cost would be 1 cent. This is a really easy way to showcase here's what your storage would cost if we implemented a chargeback system like this. Super, super simple. And the way we get this is that we dig into all the views. As you can see here, we're fetching all the views and we're fetching all the quotas as well. And then we list all the, keep. There we go. We list all the views here. Let me see here. For a view, we look at the view, and then if it has a quota, will find the view path in the quota map. So if it has a quota, we look at the quota map, we look at the root view for that quota as well. We look at the size in bytes, which is the use capacity. If it's larger than 0, and then we can convert it to terabytes, gigabytes, megabytes, kilobytes, petabytes, exabytes, whatever you want. And then we list out the total size, the number of views that we have, and the monthly cost. So again, pretty nifty way to create a basic chargeback system. This is obviously not integrated with anything else, but what's really cool about having all of this in Python is that there are so many modules where you can connect this to your email systems, to Slack, to Discord, to SMS, to anything for alerting or for updates. So if I'm a user, I could easily then we could easily build out a way for me to say DM, direct message someone on Slack, a little chargeback bot maybe, and say, hey, what's my monthly cost this month? What are we projected to be paying at the end of this month? And it will show you that. Or I can send a text to it as well using something like Twilio. And then we can easily get a response saying, hey, here's your total storage cost for the month. So this gives us a really impressive way of giving our tenants more views into how they're utilizing our systems. So if you're a tenant admin, for instance, if you're managing, let's say you're at a research university and you're a tenant admin managing storage for a bunch of other people, then you could get all that information through a system that you use daily, like Slack or Teams or text or whatever you want. So it's really cool the way you can implement this and just add on more features as you go along. It's so powerful just to get started with vastpy. With these simple examples, we've shown how to connect to your VMS, list views, check your quotas, monitor your health of the cluster, show snapshots, and also do a very simple chargeback report. All this in about 20 minutes of demo. Any questions? Let's take a look. Any examples related to vast replication, sync, async stats? Not today, but it's absolutely something that we can add in as an example. If you would like to do this, I would highly recommend, if you want to add an example like that, can you go into the Cosmos Labs GitHub repo and add an issue there? And then I'll get started on creating an example to get some stats on the replication there. Next up here, how easy would it be to include snapshot usage into that chargeback script? Does the protected paths have a similar interface? I can answer the first one. Let's see, where did that go? I don't know where that went. That question went away. Let's see. But yes, you can absolutely add snapshot information to the chargeback view. That's just calling another endpoint for the API, looking at the snapshot endpoint, and then adding that to the cost as well. So yes, absolutely, we can say, here's the view, like the view here for Jonas. This is the view that we're using. And you can see the total cost there, and then we can add total snapshot cost as well if you wanted to. There was a question around protected paths, but I don't see that anymore. Maybe Philip if you can answer that, if you saw that one.
Yeah, those questions disappeared there. But yeah, anything related to anything with protected path, all that is accessible via the API. So, these scripts could easily be adjusted to do that. When we're talking about protected path and replication for either asynchronous, replication, that's all going to be snapshot based. So you'll be able to pull that through the snapshots as well.
Perfect. So I wanted to dig into the labs a bit, and I know the screen might be a little hard to read, and I apologize for that. I hope it's better now. But as I said, all of these scripts are already on GitHub, so you can run them yourself as well. And if you're having trouble getting started, please let me know either on GitHub there or in the Cosmos community. I would love to help you get set up. And I'm more than happy to do a Zoom session with you if you want to get started with these on your own environments. Absolutely. So please let me know. The labs that we have here, they are somewhat scenario based, where we have a technical challenge and then we look at how can we solve that technical challenge. So I want to show the first lab here. We're using vastpy to automate storage provisioning, not quite, but rather quota management, and also monitoring for our fictional company Orbital Dynamics satellite data processing pipeline. We're going to be building a system that automatically scales the quota here and provides proactive alerts before our processing pipeline hits quota limits. Got a question here. Do you have an example where you query the catalog, for instance, all the files with a time over 60 days, for instance, show their paths? Yes, this demo environment that we have right now, we don't have the vast catalog enabled. Otherwise, I could demo that as well. But if you want to create an example, or if you want me to create an example in the repo, please add an issue to the repository as well. And I'm more than happy to add an example around querying the catalog for that. I think that's a great example. So Jamie, absolutely. Add an issue and I'll get right on it. So within the README here, we define the different files that we're going to be using. This, the lab1 solution is the main automation script. We also have a monitoring dashboard, which is a CLI dashboard. So that was answered. And this was answered. And we also have some unit tests. We can actually remove those now that everything should be working well. And some other requirements. There might be specific requirements for specific labs, like lab 2, for instance, requires AstroPy to properly extract the metadata from the astronomical files that we're using. So how to get started with this? Install the dependencies in the lab1 repository. You configure the solution here, we look at the configuration files, and then we run it. So I want to show you what this looks like. In lab1, we have all these files, and the lab1 solution is pretty hefty right now. It could definitely use some slimming. It's over 500 lines long, but it's because we want to make sure that we're super safe. We have different options and commands as well. So I want to show you what this looks like. If you do Python lab1 solution -- help, you can see here that we have a bunch of different options. So -- help or -h for this help message. Push to prod to actually enable production modes where we will make actual changes. Dry run, which is the default mode, where we're going to be running in dry run mode, so no changes are being made. We have a setup only, where we only check if the required views exist. So we have a few views that we have configured here in our configuration. And the monitor only, we're just going to run monitoring. We're not going to do any setup or checking if the required views exist. And I also added this yesterday, where you can actually show the API calls being made. And it's not the full API call. We want to make sure that we obfuscate the credentials and things like that, of course. But this is to kind of show you at what point we do certain things. Once I enabled that, I saw that we're making a ton of calls, obviously, and the output is a bit unwieldy. So I removed a bunch of the more verbose ones and just kept the ones that are more interesting, I would say. So instead of having all the get API calls, we'll have more of the post and the patch ones, and some of the get ones, but not all of them. So what does this look like then if we run this as a dry run, which is also the default? I can show you here. It says dry run mode, no actual changes will be made. Use -- push to prod to enable production mode. So it's scrolled. There we go. So it's looking at the views that we have configured. You can see that I have two different views here. Jonas / Cosmos Lab / raw and processed. We have two views, no missing ones. So we don't need to create any views that we would like to monitor that don't already exist. We have then configured that we're going to be alerting if a specific view is over 70 and over 90% utilized. So we'll have a little warning if it's over 70. If it's over 90, we're going to have a red dot here. So this shows that this view is actually in need of an expansion. We're almost at the hard limit. We're at 91%. So to make sure that Jordan, who's our pipeline developer here, to make sure that she has enough storage or enough space for her data processing, we need to expand that quota. So you see this here. Okay, perfect. The storage expansion is needed. This is at 91% utilization. We're going to be auto expanding this quota. We're requesting a quota expansion here. We're going to expand it with 1 terabyte, which we have hard coded as a default. You can obviously change this. And then it verifies that everything is good, that we have the view exists. The view exists again. We have basic permissions. Yes. Do we have enough availability? Yes. Can we expand within limits? Yes. So this is, again, dry run mode, where we would expand the quota, and here would be the new hard limit. So let me pull up the what this looks like here. So here is our SE lab. So you can see here, this is my quota. This is my path. And you can see that I've exceeded the soft limit already, which is 100 megabyte. And I'm almost at the hard limit. So again, 90% here, rounding off and on 90, 91%. So if I were to run this in production, it will automatically go out and change things. So here it looks at everything, looks at the views, looks at the quota, runs all the safety checks again, expanding the quota, and you can see here at the bottom, successfully expanded the quota for this particular view. And as we can see here, it has automatically enabled this new hard limit. So we're now at 24% instead of 90. So this is a really good way, a really good showing where you can see how we're looking at views, we're looking at quotas, and we're also making live changes. And every time I run this script, it will do the same thing. So if I run it today, it will do this. If I run it the next week, it will do the same thing, and so on and so on. So this gives you a way to automate more of your standard tasks that you would do. So instead of going to the UI, looking at the quotas, talk to people, see if they need a quota upgraded, you can already have those conversations and say, hey, we're going to put a quota of 50 terabytes here right now, but you have the option of expanding it up to 100. And we can automatically do that if you want, but we'll give you notifications every time we do that. So this way we can have those alerts without having massive quotas immediately. We limit the uses here. The other thing that I wanted to show you all here in this lab is also the monitoring dashboard. So this is a live dashboard that will be automatically refreshed about every 30 seconds. So this is a nice little view of what it can look like. This is, again, using a Python library or Python module called Rich. And this is giving you a nice little view of those views and those quotas there. So you can see here, we got 2 that are normal, no warnings, no critical. Okay, great. So now it's refreshing. So let's go into the UI here again, and I'm actually going to change this to 400 megabytes again. So we'll be back at 90%. So now if I run this again to force a refresh, you will see here, this is red. So utilization is at 91%. Here's the size, here's the soft limit, here's the hard limit, and here's what we have available in total. This is a great view that you could just have open on a separate monitor if you wanted to. So you can see here that we have 1 normal, 0 warnings, and 1 critical. You can see when it's last updated and so on. So again, gathering information from various different inputs or various different API endpoints and collecting them into something that can be even more useful. All right. Do we have any questions right now? Okay. We're all, we got a few more minutes. So I just wanted to kind of walk you through what Lab 2 looks like as well. And Lab 2, if you head on in there, looks like this, where we have a vast database. We want to make sure that our database bucket and the schema and the tables exist before we create anything. We're processing the NASA Swift datasets. So we're extracting metadata from local Swift data files. These would obviously, these could be mounted on an NFS or an SMB mount, or they could be S3 objects in the vast platform there. So they could be anywhere. So local just means you have access to them, rather. And then we extract some metadata from these. These are light curve files for gamma ray bursts. And then we store the metadata in the vast database. And we automatically detect duplicates, and we also insert the data safely there. And once we have everything in the database, we can then search for things. So just to quickly show you what that would look like. Let's see, I have these here. So this is a demo extraction of one of the files that we have here. This is from the Swift dataset from NASA. It's using the satellite BAT, and it's surveying the north hemisphere of the stars, the sky. And this is a specific object that we're looking at. So I want to show you what kind of metadata is actually in that file. You can see here that we can extract this using AstroPy. Here's the file path. Here's the file name. Here's how big it is. Here's the file format. You can see it's actually compressed, but the file format is obviously this. You can see the dataset name, when we added it, the metadata version, also when it was last modified, mission ID, this is Swift, and the instrument type is Swift, and then the observation timestamp, and we can see the target object. The objects here are stars that we look at, and the observation timestamp is obviously when that observation was made. Now, if we were to run this, it would do a dry run. It would create the schema and table if they weren't there. This one actually already exists with one schema. So we would then start the metadata processing, scanning the dataset directory, and then look at processing all of this. But since this is a dry run mode, we're doing no actual processing. But if we were to do a push to prod, it will go out and actually ingest all of those things. Oh, yeah, not that one. Let's see. The process only. Let's see if this works. Yes, okay. So now it's processing all the files. And you can see here it's processing the files. We get this output here, and it's adding things to the VAST database here, which is really neat. And it goes through all of these. If you wanted to look at the API calls as well, you can do -- show API calls, and it will show you the different API calls. We're doing a vastpy connect here to the endpoint. Here we're actually just getting information because I already filled the database, but otherwise you would see a bunch of vastdb insert commands here. And lastly, I want to show you the search. So with this, we can search for a specific target object. I'm using the NGC notation for star numbers, and then an observation timestamp of less or earlier than 2004-12-25. And we're going out and we're querying the database here. And you can see that we have several different objects or several different files here. So maybe we wanted to just look at 2273. Then I know exactly which file I need to look at to get more information about that light curve. So again, with this, it's super powerful. vastpy and vastdb SDKs, they are so powerful. You can do a ton of really cool stuff with these. You can build out your own automation pipeline. You can build out your own monitoring dashboard. You can insert and query databases. Catalog is upcoming as examples, but you can do so much with this. And it's everything as you that I've been showing you today. Everything is already online on GitHub there under vast-data/cosmos-labs, as you can see here. So please head over there, give it a star, give it a like, give it a Git clone, and try it out. All of these have safe mechanics. They're not going to make any changes to your system unless you use the push to prod flag. So if you want to try this out in your own environment, absolutely go nuts, have fun with it, but make sure it's you've double checked everything when it comes to configuration and your secrets and things like that. All right, we got 5 more minutes. Let's see. I have a question about what is in the vastpy module versus perhaps other Python modules. I'm open to interact with vast catalog to query metadata, specifically give me the difference between 2 snapshots and list the contents of the new stuff in the newer snapshot. Ooh. That is an interesting one. Philip.
Yeah. So I did go through and answer that in there. So the vastpy SDK that's really designed more for interacting with VMS directly, and it'll be subject to the API endpoints of VMS. And there's some database interactions that we can do with that, specifically with the catalog, but it's going to be pretty much limited because it's just the REST API for it. The vastdb SDK is a lot more in depth. It's designed for the database interaction, and the catalog is a specific implementation or specific use case of the database in general. So the vast database would be the vast database SDK would be better suited to that because you do more complex queries, get all the tags and do some other things with it there. So you may find yourself doing a combination of both of those. When it comes down to like doing interactions with things like snapshots and the catalog, just realize that when we're talking about the catalog is doing an index based on the current state of the data when the catalog frame was taken. So it'll reflect live data, not necessarily what is contained within snapshots. If you were looking at wanting to look at the difference between 2 different snapshots, then with the catalog, there is the ability, when you go through and set it up, you can set up multiple frames, which is how often it snapshots or indexes the data that's in the element store. So you can look at 2 different times from the catalog, or 2 different frames in the catalog, and say, hey, what are the differences along these paths? That that basically is the difference between the 2 of them. The database is more specific to database, and then the vastpy CLI is for communicating with VMS.
Awesome. Thank you, Philip.
Sure.
And Kristen have also added a bunch of YouTube links there.
Yes, indeed. There's some YouTube links because Phil did do an entire webinar on data catalog just a bit ago. One of those links is from our short tutorials section. So I haven't mentioned that on these webinars in a bit, but we do clip up each of our webinars into small, bite-sized 5-minute, 10-minute clips based on the topic. And so those are all available for you inside of the VAST YouTube channel under a short tutorials playlist. And then we also, of course, have our long form webinar recordings. So if you want to get up to speed on any area, that's a great place to take a look. And then, of course, I mentioned our learning portal as well. Few last housekeeping things to be aware of. You will all get a email in just a day or 2 here with the recording or link to the webinar recording YouTube playlist that I gave you. That's where we do put all of those webinar recordings. And we would love to see you at our next webinar that we are hosting very soon. So that webinar is going to be next month. We do these once a month on a Wednesday. And that one is going to be a VMS overview done by the wonderful and famous Phil Wagstrom. So he's going to go through, this was more advanced, really get into those nitty gritty. If you, want that VMS overview basic, or you want to drag in someone else who needs that to that session, that's a great one. We will be sending the link to register for that along with the follow-up email that you'll receive in about 2 days' time. So with that, I think we are going to conclude. Thank you, Jonas, so much for being here and sharing with the group. And thank you to all of you for tuning in. We'll look forward to seeing you next month on our next customer training webinar.
Thank you so much. And thank you, everyone.